Ladies and gentlemen, good evening. Tonight we are going to talk about reactive programming. First of all, what is it? Why do we want to do reactive programming? And then I'm going to show some Java examples afterwards. So if you like Java, then hang on, because we're using Rx3 in the end. First of all, we are using reactive programming because we want to have some of the benefits, which are that we need a scalable framework. Scalable, this means that if you suddenly want to run on multiple threads, or if you want to run jobs in parallel, then we want to do that without changing the code, and that is possible with the observable and observer pattern. Then we want it to be resilient. That means that if an error occurs, then we want to be able to take care of it in an orderly manner, and then respond to that error. Whatever it could be to retry at some point. It could also be to back off and just say that the data is not there's incomplete data right now or something like that. And then we also want it to be responsive, and responsive is very, very important, because in the old days you would wait for the whole web page to load. For instance, let's say that you were looking for maybe you're looking for computer games on an online store, and then the whole page would just be blank until all of the games that you searched for actually was searched and provided to the client, to the UI, and then all of the games would then be shown in a list. The new way right here is to show the games that have been loaded, because there might be a lot of metadata around each game, and then those will be provided with the observable and observer pattern. That means that as soon as the data is ready, then it will be streamed to the client. So that it gives a much better, much more fluently view, because then you have some data that you can look at, and then you're not bored, and then you don't change then you don't go to the competitor, because you actually have something to look at, right? And then at some point, then you get more data. That is also fine. Then you can look at the new data that you then get. So if you have a page full of games, like 10 games, then it's okay that then you scroll down, and then there's a small wait there, and then you can get 10 more games. So concepts like that is reactive programming. In this drawing right here, we have an observable, which is the servers that is a server we will simulate in a Spring Boot project in just a minute, and it has a data source or a service that it gets data from. This will just be an array list in our example right here, and then what happens is that we have an observer that then will subscribe to the observable. So we have an observer that calls subscribe on observable, and then there are three channels. There's a data channel, an error channel, and a done or completion channel. To begin with, the data channel is open, and you will get some data, and then at some point, if an error occurs, then the data channel will be shut down, and the data will then be presented to the observer instead. If all of the data is being sent to the observer and there's no more data, then the observable will then send a done signal. That all the data has been sent, and after that, then the observer is happy and can then continue on. Or it can actually already continue on what it's doing, because this is asynchronous communication. The observer cannot do much. It can, of course, it can subscribe, and it can also filter in the data that it gets in. Maybe it gets a lot of stuff in that it actually doesn't need. Then it can filter out all the information that it's not interested in. And another thing it can actually do is it can unsubscribe. If at some point then you say, okay, now I don't need any more data. I got what I wanted, or maybe it could also be that I'm being hammered with too much. Then I would also like to unsubscribe, but usually it's because we already got the data, then we unsubscribe, and in most cases we would actually never unsubscribe. We would wait for the done signal to be sent by the observable. If it is in this situation right here, then it's actually the observable that decides the pace of where the data is going to be presented to the observer, and this means that the observer might not be able to follow up or to catch up with all the data, because maybe the observable, maybe the computer that runs with the observable, maybe that is much faster. There's much more power in that than in the client, and then we will get too much data. And to To stop that situation, then where we get too much data sent to the client, then we can apply something called back pressure. I will not go through this tonight, but it's called back pressure, and there are two. There are some techniques. One of them is to buffer the data, and then handle it when at a later point in time when our client has more CPU time or GPU time, if it uses the GPU to handle the information. So when it has more resources to handle the information, then that can be handled a bit later by using buffering. But if the client is always 100% busy, then the solution is not to buffer. Then some back pressure needs to be applied, so we will not be hammered with data that we can that we cannot use right now. So this is reactive programming. And these are the benefits. Let us try to look at an example. I have created a Spring Boot project right here. I created that by pressing File, New, Projects. Then I chose Spring Initializer. There it is. And I chose Java 15. Java 15 is out, so I might not use it. Press Next. Ticked off Java 15. I chose Gradle just because I prefer Gradle. Then I ticked off Lombok, and then I chose Web, Spring Web, like this, and I pressed Next, Finish, and then I ended up with this project right here. Actually, I can see I'm using Java 14, but that's actually okay. Let me just check right here, and it is actually source compatibility 11 that I chose. That is also okay right now. Next time I'll choose the latest and greatest instead. But the Spring framework right now is 2.3.4. You need to add this dependency right here, which is IO reactive X RxJava 3. So this is the RxJava 3. Reactive X has libraries for most programming languages. This is then the Java version. So if you are going to other programming languages, then the structure with the Observable and the Observer will become familiar to you because reactive X it exists within a lot of languages. And I think this is the web page for RxJava, and I would actually recommend that you read up on all of this. There's also a good article about back pressure, isn't there? Maybe there's not. I think I saw a good article about it. Here there's something about the back pressure right here. If you want to read up on that, I'll also make a video about it a bit later, I guess. So, but let us look at the code instead. We want to see some code, so I'll go to my main source right here, my Java source. Okay, so let us start looking at some code. So we will create, should we choose video games today? Let us do that. Package, video games, like this. Then we will create a new class, which is a video game for sale. It could also be a book. It could be whatever, right? So we will just choose game right here. And I'll annotate this with data from Lombok. So then I get the getters and setters. I get the toString created automatically. I get my equals method created automatically. And I would also like to have all args constructor, because I'm too lazy to create the constructor also. So private string. Then we have a game name, a name of the game. And then we could have a double, which is the price in some currency. And then we could have a Boolean whether, we could have a stock quota. How many do we have on stock on storage? So let's have an integer for the storage. How many do we have stocked away on storage? That is great. Then we want a game service so we can get all of these games out. So we have a game service right here. And of course, because it's Spring Boot, then we could annotate it with service, but I'm not going to use the Spring Boot part right here. I'm just going to create a unit test to show you the RX3 concepts. So let me just create a new public observable. Yes, that is. Because when we are reactive programmers, then we are not just returning a list or something, then we return a promise that data will come at some point on the data channel. And that is the observable. And here we say game, the type of observable is game, like this, and games for sale, like this. Now I'm going to create a private static final list. We're going to create a list of games. This is to simulate that we have a database with all the games, and it's a list of games, and games equals to, and then we say arrays dot list of, like this, and here we can create some games. New game, and we should have the constructor. Yes, that is name, cheese eater, and cost, maybe it'll cost 200. Yeah, 299. That's fine. And then we have a storage number. Maybe we have 12 right now that people can buy, and we will create some more games. A lot of games right here. Cheese eater. Then we can have some space shooter 2020. I don't know if these names actually exist, but I will hope that they don't, but it should not matter. It's just an example right here. Then we have something, yeah, what could this be? This could be something with worm hunter, something like that. And we have 3 left of those, and then we have maybe a tea party simulator. Yeah, that's a bit expensive, but it did not sell as good as we hoped for, so that we have a lot on stock. And then we have a, what should this be? We have this could be a fishing game, and then there could be number 9 in the sequence, and that cost 560.5. And there's no one left on stock, so we do not have this game right here, because we're going to use that to throw an error a bit later on. That's why I would like one of them not to be on stock. The last game, what should that be? It should be a very scary game, and it could cost 33, and we have 2 of those left on storage. So now we have created a games list right here. So that is where we're going to fetch our games from, and then we're going to return those. So first of all, we need to return an observable. We could do this in multiple steps, but we could also just do it like this. Observable create, and then we have an emitter. And then we have some code, and because this is a lambda and it's multi-line, then I need to have curly brackets just like I do right there. And what will we do? This emitter right here, it has some methods that we need to use. One of them is on error. We have on complete and on next. But that almost matches something we have seen before, right? Yes, it does. Data, error, and done. Very, very nice drawing that I made here earlier on, because it actually matches real life. And now I cannot get that line away. Okay, I can actually. Okay, I'll just let's go back and code a bit. So so we want to write on next. We want to give some data back, right? And if an error happens, then we want to say on error. So what we could actually do is we could say while emitter is disposed equals false, as long as the emitter is not disposed, and because it can actually get disposed if the observer chooses to run unsubscribe at some point, or dispose as it's also called. That's the same as unsubscribe. If it calls unsubscribe or dispose, then the emitter will be disposed, and there's no reason for transporting data to the observable when no one is listening, right? That would just be a waste of energy. Then we say, and let's create an integer. I less than games dot size, and then we can. So that means that now we have created a while loop. where we go through each of the games right here. Then we can send games.get and then the index. So now, so now we're just pushing all the games right there, but with the on next right here. When we're done, then we will call the on completed. So this is on completed. So now we first we open up the channel, the data channel, and then we set a done signal when we're done. And we could also introduce something with an error. Let us just do that right away. So that means that if I say if games.get we can say that if there's no games in storage, get storage. If that equals, if that is 0, then we will use the emitter to throw an error with the on error, and then new runtime exception. There it is, and then we say, whoops, the game is not on stock. Or on, there's no one in storage. Then we also give the game, so we get the game also. Of course, we could actually make this a bit nicer. We could say that we create a local variable right here. So here we have the game, and game, and game, and game also there. So that means that now we will, if the storage is 0, then we will throw this error right here instead. And that means that then the onComplete will never be called, because on error is called instead. So this is our service. So this is our server. Let us create a client for that. We'll just create a unit test. That's the easiest way to do that. Yes, where is the member? Why can't I see the member? There it is. I'll take off games for sale. Okay. And for some reason, I don't know why IntelliJ doesn't write public in front, because it does not work without public. Then we cannot run. Then the test will not be run. It's a bit annoying, but that's just how it is. If someone knows why it does that, why IntelliJ does that, or if there's something I've misunderstood, then just let me know as usual in the comments. Here we have the game service, and then we can say game service dot games for sale. And then we have an observable, and nothing happens because we have not subscribed to this. So, and to prove that nothing actually happens, then we can have some system out right here. Start emitting games, and here we write done emitting the games here, or done. You could also say sending, start sending games. Done sending games right here, because then when we run our unit test right here, then we get some output, and then we can actually see that nothing should happen, except that the test should show green, of course. So while that runs, let us write some code. So now it says test results, everything is okay. We ran some good tests and everything was fine. So now we will say game observable dot subscribe. As soon as we start subscribing, then the data channel will open up, and we will actually, the observable will give us the data that we expected, or that we wanted, and then and then we are good to go. And then at some point, of course, if an error is thrown, then the observer will get that error and need to handle that. And that is the resilient part of this setup right here. And then in the end, we get the done signal. So, but let's go back and get this subscribe right here. We can use 3 lambdas for on next, on error, and on complete. Let us start with that. So first we have our data right here. We got some data. And here we have the game data. The type is actually a game here, so we could also say here we got a game. And we could also have used the method reference right here if that's what we wanted to instead. And here we have the error. When dealing with lambdas in Java, of course you can take the data like that, and then and then have a one-liner, but you could actually also just make a method reference, then it will be sent to system.out.println if that's what we wanted to. But yeah, enough about that. So I made another video about lambdas, by the way, where I explained this and show how this works. Lambdas and method references. But here we have the error. So here we print out the error again. Error occurred, and plus the error. And then we have done right here, and in the done lambda, or in the done handler, that there's nothing. We just say we are done. We are done. Thank you for the data. Thank you for the data. Like that. Then we're done. So this is yeah, this is completely valid to write this. So I will now run my observer that observes my observable, and let us see what actually happens. Whoa, we got some data. We got the Tea Seeder game, the Space Shooter, the Worm Hunter, the Tea Party Simulator, the Fishing Game 9, and then an error was thrown because the game is not in stock. And that was the Fishing Game 9. There's none of those in stock. So we got an error. And then when we're done, then we actually got done sending games. We actually also got that. But we did not get it. We did not get it as an event, so we did not get the done event right here. We are done. Thank you for the data. We did not end up right here, and that's because we ended up in the error. So as soon as we end up in the error channel, then the data is closed, and we don't get the done channel. So the completed channel is only for when everything goes as expected, and we got the data that we needed. Let us try to set this fishing games to 10 instead, and now we should get all the data, and then we can see how that would actually look instead. So now we also got the fishing games right here. We got this very scary game, and then we got done sending games, and we are done. Thank you for the data. So that means that now we ended up in the completed area right here, in the completed handler. Awesome, awesome, awesome. Now, what if I would like to unsubscribe in the middle? Then we do something else. We need to create a new observer. New observer, not observable, observer. The observer observes the observable. So it's quite simple, right? So observer. So we have this one right here, and that is an interface. Observer is an interface, so that means we need to implement a lot of methods. Unsubscribed, on next, on error, on complete. You could recommend the 3 of them. You can what do you call it? You can yeah, you know about three of them right now. But unsubscribe, that is your new method, and that's the one that we actually need, and that is why we are creating an observer like this, because we actually need the disposable right there. I will set that as a member variable, and when on subscribe, then I will say disposable. Okay, I misspelled it, but that's okay. Equals D. Shift F6, refactor to disposable. On next, and then we could copy some of the data, right? We could say something like if game starts with game.getName. If that starts with, we're looking for one game, right? So if that starts with, let us pretend that we're looking for one game. So if it starts with space, a worm. If it starts with worm, then we stop. Then we unsubscribe. Let us say that. So if it starts with worm, then we take our disposable, and then we say dispose, or else then we just system.out.println the game as usual. On error, yeah, we don't need that because we'll not end up right here. I'll add it anyway because I'm going to push the code as usual to my GitHub account. Complete like this, and now that we okay, so now we have an observable right there, and we have an observer right there. So we need to take our observable, game observable, then we need to subscribe, and here we can use our observer like that, and it does not return anything. Let us see how it goes now. We got the Worm Hunter as the last game, and then we got this done sending games. Awesome. Awesome, awesome, awesome. We did not get our uncompleted because the server or the observable did not send the incomplete, because it suddenly it was just disposed, and that was in this situation it was the observer that unsubscribed by using the dispose method. Pretty awesome, right? Another thing we can do with or observe when we subscribe right here, we can actually also filter. So we can actually also say we want to filter. We can do a lot of cool stuff, but one of them is to filter, and then we can have a predicate right here. That means that we have a game, and then we say we only want the game that get storage, where get storage is greater than 10. And then subscribe. So now we will only get the games that are greater than 10, and we will let us not unsubscribe this time. I'm going to comment it, then you can still use it from from my GitHub account. Let me just check which games were greater than 10. So we have actually 2 games, right? Cheese Eater and the Cheese Party Simulator. So let us run the code again, because now we are filtering array. So that means that we will get a lot of noise, and then we can just filter and get the data that we actually want to. It is still being sent to us, so it's still a bit of waste that we get all of this data. But yeah, so here we have it. The filter works. Cheese Eater, Tea Party Simulator. Thank you very much for watching. Have a great evening, and hope to see you again soon. Feel free to ask questions as usual. Bye bye.